Okay, so let's start chapter 10. Up till now, we have seen extensive form games in which we have chance moves, but we haven't yet seen an extensive form game in which we have imperfect information. So players not knowing what has happened so far. In order to model something like that, basically adding that allows us to model situations like this, where player 1 is choosing between C, D, and E, and then player 2 can choose between F and G or H and I, but here player 2 doesn't know whether C has happened or D has happened. This dotted line is to show that C and D are part of one information set. Okay, I will define that a little more carefully. First, let's define HI. HI, capital HI, is a set of histories after which it is player I's turn to move. In this game, H1 is just the null set. So it's player 1's turn to move when nothing has happened so far. And H2 is C, D, or E. Right, it's player 2's turn to move after either C has happened, or D has happened, or E has happened. An information set is a partition of this history H2. So here, I2 will lie in either CD or E. What that means is the information that is presented to player 2 is either that C or D has happened or that E has happened. Introducing this notion of an information set allows us to capture that uncertainty from the perspective of player 2. In order for C and D to both belong in the same information set, it has to be that the actions that are available to player 2 after C should be equal to the actions that are available to player 2 after playing D, after player 1 has played D. If the actions that are available to player 2 are different, right, if instead of FG here we had J and K, then player 2, just by observing the actions available to player 2, would surmise what has happened. And in order to preserve these two belonging in the same information set, we can't let that happen. So the only time C and D, or any two actions for that matter, the only time that two actions would be in the same information set would be if the actions that are available to the player after that history, after those histories are exactly the same. So let me write it out. In order for H and H prime to be in the same information set, it must be that AI H equals AI H prime. We can also define AI II as the set of actions available to player I after observing an information set II. Okay, I'm going to get rid of this. And talk about how to define this kind of game more formally. So compared with our last definition, the only thing that I'm adding here is information partitions for each player. Let's do this. I'm just going to tell you the components of this formal definition using this game as an example. So what we need first are players. In this case, there's two players, players 1 and 2. Then we need terminal histories. Like last time, those terminal histories will either be CF, CG, DF, DG, EH, or EI. Terminal histories are basically the set of ways in which a game could play out from start to finish. Then we need a player function. The player function assigns whose turn it is to move after each history. So it takes as an input the history and tells you whose turn it is to move. So P of phi here is player 1, P of C equals P of D equals P of E equals player 2. Then we need to talk about chance moves. In this game there are no chance moves, but if there were chance moves, so if there was any exogenous uncertainty that's not caused by one of these players, then we would have to define, for every time the chance plays a role, for every time that chance moves, we would have to define the probability distribution of the actions that chance can take. So if chance puts you in one of two paths, then we have to define one, when chance does that, putting you in one of those two paths, and two, we would have to define what the likelihood of chance putting you in each path is. In this game, no chance moves. Then we need information partitions. I1 is just phi, and I2 can be either CD or E. And so we just write it out like that. And finally, preferences. Like in an extensive form game with chance moves, those preferences will need to be defined over lotteries over these terminal histories. So you have normal, standard von Neumann-Morgenstern preferences here. All right, see you in the next video.